There we go. All right. Always, always, always check for a GCF when we're factoring. So on something like this one, x squared minus 7x, what is common between all the pieces? X. So the factored form of this is we take the x out, and what's left over? X minus 7. Because they both have x in common. When I divide each of these terms by x, we get x minus 7, right? We're looking for what's shared between all the pieces. So on this second one, 4x squared, y minus 28xy. What do they have in common? 4xy. So when we write this factored form, we've got, not inside the parentheses, sorry, my brain, 4xy. And then what's left over after I take that out? X minus 7. Right? Even on big BCs like the bottom one, which I can move. I can move it higher. Let's zoom it in all the way so you can see it very well. Making sure we can see the one above, just in case we're still writing. So we've got 9a squared b to the 4th plus 27a b to the 5th plus 81a cubed b cubed. What do they have in common? 9a b. Just one b?
It's 3 b's.
3 b's. I could take a b cubed out of all of them. I could take b cubed out of all of them. So when we write this factored out, we have our GCF out front, 9ab cubed. What is left over when I take 9ab cubed out of this guy? A and b. So if it helps you, make little baby fractions of these and just simplify the dang sucker. 27ab to the 5th divided by 9ab cubed. That's what we're doing right here. That's this guy. What's left over when I take 9ab cubed out of 27ab to the 5th? 3b squared. Then I have 81a cubed b cubed. 9 a squared. That's it. Okay? Is nasty, is gross, but that's what it is. It looks nasty. But it is what it is. We're going to have some really ugly looking expressions in here sometimes. I mean, you saw that on 1, 2. They are not always pretty. They are rarely pretty. But they are what they are. And we accept them as they are. Okay, so we're always going to check for a GCF first. We got more factoring to do, though. Questions on any of these guys? All right. We're going to look at some trinomials. This has some strong Algebra 2 vibes. You can absolutely do this with the box if you remember how to use the box. We're going to do a lot more factoring and grouping, which is still it's the same process, but it's just more organized. Either way, we can still use that X frame that we did in Algebra 2, where we figure out how this middle term is split by taking our A times C and our B, figure out what multiplies to A times C and adds to B. Those are our two terms, right? Kind of familiar? So when we look at this first one, x squared minus 7x plus 12. I wish I moved that somewhere else. We're looking for a pair of numbers that multiplies to be 12 and adds to be -7. -3 and -4. When our A value is 1, that just straight up tells us our terms. X minus 3, X minus 4. If our number in front here, if this is a 1, all we've got to do is the X. And it spits this out. Our -3 is here, our -4 is here. There's an additional step if we have that. So hopefully, like, that's a shortcut we should have learned at the end of Algebra 2, hopefully. This will save you a bunch of time if you do not have to box or, like, group this. So then we're going to come down here. Do this one. So we have A times C, 1 times 121 is 121. B is -22. What's a pair of numbers that multiplies to be 121 and adds to be -22? -11 and -11. So we get X minus 11 and X minus 11, or X minus 11 squared. Starting to notice those perfect squares would be a great thing to notice in there. If we remember that difference of 2 squares one, that would be a handy one to notice. What the heck just happened there? There we go. I don't know. My computer's in a mood is what that was called. I'm just zooming that in so we can see it. I'm just going to give us a little more space at the bottom so that I can move that up higher and it's not right at the bottom of the screen, because I know we have a gazillion heads in front of some of us, because in the back there's like 20 people in front of you. If you guys ever need me to move things higher or change colors, please let me know. Like, I can always do that. All right, one more of this A value of 1, guys. So our A value and our C, 1 times 15 is 15. And our B value is 8. So I need a pair of numbers that multiplies to make 15, adds to be 8. 3 and 5. Pros at this. The tricky on this one is remember that this is an A, not an X. A plus 3, A plus 5. I know it's been a minute since we factored. Yes, my friend. On
grading and stuff, how strictly grading? Like, if you get some of it right.
I love partial credit.
Okay.
I love partial credit. I give partial credit all the time. When it comes to, like, answers, I do have to be specific on answers and stuff, but when I, like, pass back homework and stuff, if I've given you partial credit, I've written why.
So
okay.
No partial credit?
Oh, always partial credit. Always partial credit. If it's worth more than 1 point, it is absolutely available for partial credit. If it's 1 point, we're debatable, but probably I'll still give half points. I have to be kind of strict because it's IU and IU specifies some of the things, but I love partial credit. Like, everyone who's taught this class told me that's going to be the hardest part for me, is grading harsh enough for IU, because I try and be nice. I try. Okay. So, we're going to do some bigger ones. These are all going to be perfect squares, or all squares, x squareds. We'll look at some cubes in just a second. Hopefully we'll have time for cubes. Otherwise, we'll get to it tomorrow. So first things first, when we are factoring, what's our first step always got to be? GCF. Does this first one have a GCF? What's our GCF? 2. That's going to leave us with, that's not it, 7x squared plus 10x minus 8. And then we're going to use our x to help us figure out what this middle term's really supposed to be. So we take our a times c in here. We have negative 56. And our bottom number is 10. So I need a pair of numbers that multiplies to make negative 56 and adds to be positive 10.
Where'd you get negative 56 from?
7 times minus 8. A times C. Good question. This one's going to take a second so it doesn't pop easy into the head right here. 14 and negative 4. When in doubt, look at your factors of the top number. Like, you can straight up say, all right, what times what makes 56? 1 and 56. 2 and 28. No 3. 4 and 14. No 5. What is that number? There we go. No 5, no 6, 7, and 8. So when in doubt, make a list of your factors like that. And you can see which one, and since the top number is negative, we're looking at a difference. This is the pair that has a difference of 10. That's the kind of fast way to figure out that pair. If you get stuck right there, make your list. What this tells us, since I have an A value that's not 1, it tells us how this term splits into 2 pieces. If you did the box, this would be where you're filling in the box, and that's okay and that's valid. You can use the box. We're going to do 2 7x squared 14x plus 14 minus 4x minus 8. All I'm doing is uncombining like terms. In which case, I'm going to break this thing into pairs. The fact that they're doing this one as the first one really annoys me here. All right, I'm coloring over this next one because I need the space. I'll bring that back when we need it. But right now I need this space because I don't want to have to write smaller. What we're going to do is we add parentheses on our own, busting this into pairs. Then we're going to look at each pair and find the GCF of each pair. So if I just look at seven x squared plus 14x, what is common in there? 7x, right? So I could write this pair as 7x times x plus 2, right? See that piece? Oh, shoot, that is not what I want. We're just gonna... This 2 or this 2 up front? The one out front. I'm just looking at that pink pair right now. So he's still there. I'm just trying to make it so we can see what the heck is happening because there's a lot of pieces here. So I'll just do the 2 in black way out here. Because he's just kind of sitting there. He's chilling. We're ignoring him for now. He's just chilling. So then we have down here, we're going to look at this pair, and I'll do it in blue. What is common between negative 4x and negative 8? Negative 4. What's left over when I take out negative 4? X plus 2. If these 2 pieces match, we did it right. The 2 pieces left in the parentheses. And what this gives us is our factored form. This 2 is still hanging out in front. He's an obnoxious little line leader. We're going to write our piece that we had here. That's too many parentheses there. X plus 2. And we take our 2 little pieces that we pulled out. 7x minus 4. This is called factoring by grouping. It honestly works way better when we have anything bigger than perfect squares. It works on every kind of function. The box works really great on squares, if you know the box. It doesn't work as great on things like cubes. What's that?
Are we not going to move x plus 2 to the power of 2 or no?
No, we're not gonna have the x plus 2 squared because it's not times this. It was 7x times this and minus 4 times this. So what we've done is we've factored out x plus 2 here. We're breaking them into chunks. It's weird and it's annoying and it's a little tough to get used to, but it's honestly super duper more useful than the box because it works on way more types of functions. And we'll continue working with it tomorrow because we have less than a minute to develop. The homework is going to be not due tomorrow because we got to finish this up, so we do Monday. Okay? We'll finish up more factoring stuff tomorrow.